Okay, hi everyone. Thanks for coming. So we are the Nouveau, the people from Nouveau who are actually at FOSDEM today. So there's Carol Herbst, the new hire from Red Hat, working full time on Nouveau. Then there's Pierre Moreau, who is also working on Nouveau, but from the community aspect. I mean, as a community member, he doesn't get paid for it, but it's something that he's been doing also related to his PhD in graphics. Ish. And I'm Martin Perez. I'm an Intel developer, but I also am allowed to work on my spare time on Nouveau, and so this work has nothing to do with Intel. So this is the legal disclaimer. I'm safe now. Okay, and I'm gonna hand over the mic to Carol.
Yeah. Short summary about what we want to talk about. First, I will give a short summary introduction about Nouveau. Then I will head on to talk about Pascal support and what we were working on regarding power management. Pierre wants to talk about user space stuff like graphics and compute and so on. And then Martin wants to finish up with community stuff and the conclusion we have about things. So Nouveau is like the open source driver for NVIDIA GPUs on Linux, and because it's usually used as a default driver for NVIDIA GPUs, we want to provide a good out-of-box experience for the end user using their machines. And what we actually also want to have is like that users are able to use it for games and also compute workloads, which sometimes works, and for some games it doesn't work out so well, but we want to work on this. So we support like most of the NVIDIA GPUs since all of those since 1998. We have 2D and 3D acceleration working on like GPUs since 2003. Non-officially, we support up to OpenGL 4.5. There are some trademark issues, so we aren't able to expose this yet. And there's also like the work somebody worked on DirectX 9 support through Wine, so it's also nice. And we are able to do accelerated video decoding on GPUs between 2004 and 2013. So, talking about Pascal now, it's like the current generation of desktop GPUs, which were like released 2 years ago, and it's so far the most locked down NVIDIA GPUs. So we really can't do much on those because you need sign stuff for lots of stuff. So what we're currently supporting is mode setting, which you kind of need for display stuff and all the basic graphics to get something on the screen. So this is nice that this works. We also have 2D and 3D acceleration, but we kind of had to wait for 1 year or more for this because we need signed firmware to really do it in an efficient enough way so users can actually use this. And we are also able to read out like the temperature on those GPUs, but
Just one thing, the reason why we have to wait is because they are signed firmwares, so only NVIDIA can put them out. So that is why.
Yeah, otherwise on GPUs before that we wrote the firmware ourselves and we can just use our firmware, but not on Pascal and also not on Maxwell. So, but those issues now are more likely, they are more related to Pascal in general. We can't change the fan speeds, we can't reclock the GPUs, we can't change the video bias, which we need to figure out what the bits in the video bias are there for. So we basically just switch something and see what difference it makes for the NVIDIA driver. So we can't do this, and we are also not able to read out the current power consumption, which we need for power capping, stuff like this. So heading on to power management. Lute Paul from Red Hat was working on clock gating, which is kind of a feature to turn off certain parts of the GPU to reduce the power consumption, which is a nice thing for laptops, but is also a little bit important for performance because you can have higher clocks and more performance this way. We hope to get it landed for Kepler in a few weeks or days, whatever. Martin was working on fan management stuff over the last years. We kind of like, obviously we needed to have higher fan speeds on temperature. It's supported pretty well on most GPUs, but there were like those kind of rare GPUs where there's a weird fan calibration we have to do, and since now we don't really were able to figure it out, Martin did some good work on this, but it's still like he says it makes no sense. So, but it's important because there are some users with really loud fans and it's super annoying. And we hope that NVIDIA is about to release some documentation on this, so maybe we get with a working solution for this soon. Ben, Roy, and I were working on reclocking stuff. We supported for Tesla and Kepler GPUs pretty well. And there's some ongoing work on Fermi, which I hope will be visible to users this year. There was some pretty good stuff done this year, so it's nice. I was also working on thermal throttling, which is kind of needed. Like if we come to a good performance on GPUs, it might be that the GPU is getting pretty hot, so it's nice to be able to reduce the clocks in those cases. And for on-demand reclocking, we also need to figure out on the GPU how much of the GPUs you use and what loads there are. So I was also working on this. Power monitoring is important in case you have like your self-built system or whatever, and you really have to be aware of the power consumption of the GPU. So what we have to do is we have to figure out what it's like the official power consumption on the GPU, and we have to be like cap this, that we don't go above this. So I was also working on this.
So now I'll be talking about user space and mainly the graphics part and OpenCL as well. What's been happening in the past year or so. So I'm not going to talk about Tesla because Tesla hardware was released in 2007, 2009 and is only capable of OpenGL 3.3. So there has been no progress to higher version of OpenGLs because of that. But on the other hand, Fermi hardware and more recent hardware, they can handle higher versions of OpenGL. And OpenGL 4.4 and 4.3 and 4.5 have been landing in the past years. However, since OpenGL 4.4, to advertise the support, you need to pass the conformance test use from Kronos. And you need to submit results from that conformance in order to advertise 4.4, and that hasn't been done for Nouveau, so we don't advertise 4.4 and 4.5. So by default, you will get OpenGL 4.3.
Just on this topic, there's been a collaboration between Kronos and the Xor Foundation, so as open source drivers could submit conformance tests or results without paying, because usually you would be paying thousands of dollars, which we do not have as, well, we're just open source developers. So so this is a good shout out to Kronos because that's very appreciated, and yeah, that's it. Yes.
And the conformance test use is also now open source, so we can run it.
There are some parts that are closed source, but I think we should have access to that with the agreement.
Yes, so most of it at least should be open source. Regarding Vulkan, so Carol has been working on the NER to NVRA translation path, which so Intel has been working on SPIR-V to NER. So if we can get NER to NVIA, which is the intermediate representation we use in Nouveau, then we'll be able to ingest SPIR-V, which is needed for Vulkan support and also for OpenGL 4.6. Before you could use SPIR-V through an extension, but in 4.6 it's a core feature, so we need that support. And hopefully there might be some basic Vulkan driver this year. There is some work that needs to be done in the kernel part, and then it's implementing the API. So now on to compute. So I'm going to talk a bit more about SPURVY. So as I said, SPURVY is being used in Vulkan and OpenGL, but it's also now used in OpenCL. So before, in OpenCL 1.2 and 2.0, you have to use an extension to use it, but in 2.1, it's now a core feature. So I've been working on adding SPURVY support to Clover, which is the OpenCL implementation in Mesa. So if currently there is only one driver with which you can use Clover, which is the Radeon driver, possibly Radeon SI as well, which is currently using the LLVM intermediate representation for representing the kernels. But I've been switching it to SPURVY, so that makes ingesting SPURVY directly also easier. So if you want to test that out, I've sent 2 versions to the mailing list already, and there's a 3rd version that's being working on. You will need those softwares on the slide, and I'll put a more detailed explanation on how to do things and add a link to the events webpage, so you can more easily get that working on your computer if you want to try it out. But I've also been working on OpenCL support for Nouveau through SPURVY as well. So instead of going from SPURVY to NER and then to NVIR, I've been working on translating SPURVY directly to NVIR. So what's the current status for that? So most arithmetic relation bit operations are supported, as well as atomics and conversions operations. You can call functions, and you can use basic control flow like if-else statements and loops. Image support is a work in progress. It's not there yet, but getting there. There's some more memory operations that need to be implemented. And what's still missing, it's mainly group operations and a lot of OpenCL specific operations, even though Carol already implemented a few of them. So OpenCL also has conformance test suites, and which is open source. So currently I've been running the test basic, which tests basic operations you can do in OpenCL, try to have a broad overview of what's possible. And we have 36 out of 95 tests that passes. But 27 of the failing ones are image related. So once the image support lands, the passing rate should get improved by quite a bit. And if you want to try that out, it's about the same prerequisites as for the SPURVY stuff in Clover, with difference on the branch, which isn't pushed out yet, but I'll do that soon. And regarding hardware status, Tesla needs some more love on the memory management, but otherwise, other families should work. Maxwell and Pascal might need a little bit more tweaking, but basic stuff should work there. And now I'll let Martin talk about the community.
Okay, I'm surprised that we are already on the time that we're expecting. Surprising. So yeah, well, I'm going to talk about the current members and the history that we've had with NVIDIA, which is very interesting. Okay. so right now we have 3 Red Hat developers working on Nouveau. It's a huge improvement. We used to have only Ben Skeggs working on it for, I don't know, the past 10 years. And then Leopold got hired, I think it was last year. He's been working not full-time on Nouveau, but he's been helping quite, oh yeah, sorry. Yeah, there's been, well, good work there. And then Carol has been hired this year, so...
Last year.
Oh, yes, you're right. Darn it, it's 2018 now. Okay, last year. Well, a couple of months ago. Boom. So, yeah, so now he's working full-time on reclocking, Mesa, or compute-related stuff. It's not, super clear. It's generally working on what is needed to be worked on, which is good. It's exactly what we need. But we also have community members. So not everyone is listed, but that's the main ones. So Riskid, I'm not sure how to pronounce this. It's Australian, so it's been working on the tooling, so IGT or ShaderDB, so that's pretty good. That hopefully Nouveau is gonna get IGT working quite well on it. And he's been also working on thermal management. He really wants to get. He has a laptop with a Pascal GPU, and he would like to get it to work as well as possible. Then Ilya Mirkin is, a top star Mesa developer. He's been working on the hardest features of for OpenGL, and is really doing an excellent job. Unfortunately, we had Samuel Pitoise last year, or 2 years ago, working and doing a lot of development for Nouveau, but he got hired by Valve and is not working on mostly on Radeon, but is still here for reviews and things like this, so it's still nice to have him. So there's Pierre Moreau, you heard. Me, I'm doing mostly fan management and power management. That's what I've been doing for the past 8 years. But fan management is the only thing that actually works. The rest is, well, not even for everyone, but yeah. So, I mean, that's unfortunate, but this is what fan management and power management is. It's like, how many ways do you need to dig a hole? Well, apparently for fan management, about 10 ways in 10 years. Pretty good. Roy Split is also working on DVFS or reclocking related stuff and compiler optimizations. So yeah, Roy started at the same time as me, so in 2010, still working on it. And well, maybe someone in the room would be interested in or in the stream to join us. But I'm going to talk a bit later about this. So now onto the relationship we have with NVIDIA. So in 2013, we had the first real contact really for Nouveau. The first real contact was when they said that they would not hinder us, but not help us. But in 2013, which is already good. In 2013, they brought some documentation with them at XDC, and yeah, it was NDA free, so we could just use it any way we want. And we got an email contact that we could where we could email questions, and it's been working. It's not fast, but it's been working, so that is nice. And they are willing to improve the out-of-the-box experience on Nouveau, which is the same objective that we have. In 2015, they had a new NVIDIA developer who got hired just to work on Nouveau, or most of his time. And he had its support for the Tegra K1, X1, and X2 in Nouveau, so that was really nice because it even led to a product that was based on Nouveau that I don't think a lot of people know. And that's very, very interesting because we would not have thought about this, but good. And he also wrote the secure boot for Maxwell, which is all this firmware, signed firmware procedure to how to upload it and how to get everything ready. It's black magic, of course, and it's highly undebuggable when you don't have, well, the right information. So that was very valuable. Unfortunately, he left last year, the company, and since then the contributions have been, way lower. And it's to be expected as the organization reorganizes to provide the same output. And but yeah, apparently 2018 is a new hope because we started by getting a new documentation dump for the vBIOS table. And I'm going to talk about this a bit after. Yeah, so this is going to be very useful, and I also asked them for help on the weird fan management issue because I just couldn't figure it out. It really is nuts. Okay, so about almost the last slide. Maxwell 2 GPUs or Pascal are the most locked GPUs that you can think of, probably. You can't do anything without a firmware, so accelerated graphics, it takes us about a year to get. When you've got a release of a certain GPU, it's going to take about a year for us to get the firmware ready, and that's consistent throughout the last 3 years, so hopefully it's going to improve. Then the fan management, well, really we can't do anything unless the firmware is provided. There's multiple engines, and one of them is really crucial for power management, and this crucial firmware we do not have, except for a couple of platforms, the Tegra ones. So we are pretty much stuck for fan management, reclocking, power reading, and then the last one is really important, the vBIOS reverse engineering. We cannot do, if the way we've been doing reverse engineering of these vBIOS is by as Carol said, we just change bits in a 64 kilobyte binary, and then we just look at what output we get. And so that's what we've been doing since forever, to reverse engineer what the BIOS was about. And well, we can't do that anymore, starting from Maxwell 2. So how do we add support? So luckily they don't change a lot of things, so you can start guessing things. You can look at numbers like this 3000 here looks like the clock, and I see it somewhere else, so it could be a clock. But then we can't verify what is going to be the limits and if it really is that and nothing else. So that's why we really need documentation from NVIDIA now on the BIOS, like full documentation of the BIOS. It's not going to be perfect because, of course, documentation is never, but at least we'll have a better clue of what is going on. But related to the BIOS documentation, they released a website that allows you to sign your firmwares, and apparently even some NVIDIA developers didn't even know about it, and we heard about it last week. So there's something going on.
It looks like there were links to that website in July 2017, so it's not new.
It's not new, okay.
But I worked for NVIDIA and I had no idea it existed.
Okay, so what Arthur said was that 6 months ago the website got introduced, and it doesn't know what it is about.
I think it's mostly used by overclockers and stuff like this, so they're just changing the video BIOS to get higher clocks and so on. So I think that's the main reason.
Yeah, so for us it still is going to be a pain because we used to test. I mean, I have scripts that automatically change numbers and then update. And reload the BIOS, and then reload the driver and start X again and get some values and then go down. And I do this like every 4 seconds for weeks at a time. So if I need to ask, the system to sign stuff all the time, there's no way it's going to work. But anyway, Nouveau is improving. It's still the default driver on all distributions. The GL driver is in pretty good shape, with OpenGL 4.4 and 4.5 coming as soon as we can get the CTS failures down to 0. Well, performance needs to improve for 4K displays, and it's unfortunate. Without reclocking, it's not going to be possible, so we have a lot of work there. But the power efficiency for laptop users is going to improve thanks to the clock gating patches that I reviewed last week, so hopefully they're going to land. And yeah, so please join the fun, because we are an interesting team distributed everywhere. There's a lot of challenges in basically every aspect. And if you are a student, then you could join us through the Google Summer of Code or the Xorg Foundation's Endless Vacation of Code. And yeah, we'll make sure that we have projects for you. See the corporate guy here now. Then that is it.
Yeah.
Any question?
I want to tell a little bit about the GSOC stuff. I took some time, and I think throw out like 10 project ideas on the website. So if somebody's interested, please look there. There are lots of ideas. So.
Stupid question, but is it possible to extract the firmwares from the proprietary drivers?
We are quite sure it is possible to extract the firmware from the binary driver, but I think the people who was looking into this was like, yeah, I don't no idea where it is, and it's like stored in a way it's not fun to extract. So there are ways, but
And even if we do extract it like in a hacky way, we can't redistribute it. So that's a problem. We cannot redistribute the binary.
Yes, but you could include a script with your driver that users could run.
So what he's saying is that we could have a script that extracts it from the proprietary driver and then deploys it on your. Yeah, exactly. So we actually have this for video decoding, and unfortunately, it's not easy to generalize it for these firmwares. They are not stored in the same way, and obviously they've been trying to hide it. It may even be, not signed, well, not signed, but like encrypted, but the key somewhere else. I mean, the thing is, it's obfuscated, that's for sure. Any other question? Oh, okay.
Ask us later.
Yeah, you can come to us and we'll stay outside so you can answer your questions.